We're just going to go over the revision slides for chapter 4 on linear relationships, okay? So it pretty much just goes in order from chapter 4A all the way to 4K. I've just removed any parts that are related to students who are doing advanced math stuff for next year if they plan on doing so. If they want to know how to do that, then they could just look at the actual slides themselves, depending on the actual chapter, okay? So yeah, here we go. Um, So, how to draw a Cartesian plane. Hopefully, everyone is comfortable with this, but we'll just talk over it again, okay? If you remember, I gave everyone a sheet just telling you how to actually draw the Cartesian plane. So, all you want to do is draw two lines, one going from left to right, one going from left to right here. That's the x-axis, and then you have top to bottom, which is the y-axis. Now, you have to make sure that they cross each other. So similar to my diagram right here already, that's how it's supposed to look like. Um, so number two is you need to label them with numbers, okay? So this is what we call scaling right now. So scaling is very important. I am making a note of it that you need to make sure you scale everything properly and it has to be the same distance, okay? And you will be penalized if you don't do the correct scaling, okay? So just make sure you do that. And then step three is just marking the origin. So if you don't know what the origin is just pretty much the coordinate point 0, 0. And in my diagram, it's pretty much where the two axis lines meet up, okay? That's basically all you have to do. Now, you don't need to always mark it, but, just point it out. It'd be nice to have, okay? Next thing is knowing how to read or write coordinate points. So just remember, coordinate points are always written in the form of bracket x and comma y. Okay, close brackets. So just know the x value always comes first. That's x, and then you got the y coming in second. Okay, so just be careful whenever you're reading coordinate points, and then you put it together. Okay. Now, let's just do an example right here. Let's just be very simple with it, okay? So over here, I've got 4 points. I've got one in blue, red, green, and purple here. Now, I can just indicate, I'll just circle it so you know where they are, just like that. And it's your job to just tell me what's the coordinate point, okay? So let's just have a look at our graph right here. Now, these have been scaled very weirdly. They've been scaled using the number 2. So that means every big marking increases by 2 every single time, okay? So that means you just got to be careful with the in-betweens, okay? So I'll just mark some of them out for you. And then I will even fill them in for you, okay? So we have 1, 3. So I'm just working through the x-axis first. So I start with -6, -5, -4, -3, -2, -1. Then 0, 1, 2, 3, 4. Okay. And then now we work on the y-axis. So I've got -4 right here. That means this is -3, -1 right here. And since we hit 0 at the origin, we now move over to the positive numbers. Okay. So let's just label them out. Okay. So I'll just say for blue, let's have a look at the blue dot. We can see that the coordinate point is, let's look at the x-axis here. So it sits at +1. And now we need to find what the y value is. And we can see just based off that, it's also +1. So that means this coordinate point is 1, 1. Now let's do the red one. So let's have a look here. Just going based off the x-axis, it's at +3. And now we find the y value. It corresponds with -2. So this coordinate will be 3, -2. Now the green one, it's a bit tricky. But if you have a look here, just look along the x-axis here, like where does that green dot sort of lie on? As you can see, it lies on the number 0. So we know the first number is going to be 0 like that. And then for the y value, you just go down. Okay, I see it's at -4, so I'm going to write -4 instead. And finally, we have purple, which is the fourth dot. On the x-axis, it looks like it's -5. And for the y value, it is on -2. So that means the coordinate point is -5, -2. Okay, just like that. Now, the x and the y intercept, very, very important. Okay, you need to know what they are, but it's pretty simple. Okay, so the x intercept is where the straight line crosses the x axis. Okay, so I'll just highlight that real quick. The x intercept and the y intercept is where the straight line crosses the y-axis. And this just means when the line crosses the y-intercept, the value of x is 0. And you can tell from the graph itself, yeah, if you're reading it as a coordinate point, if read as a coordinate point, it makes a lot of sense. So this here would be considered, let's have a look. So this point right here on the coordinate point, the x value is 0 and the y value will be the number 4. And for the x-intercept, the x value is at 2, positive 2, and the y value for it would be 0. Now, this is very important because this will help us whenever we're drawing graphs and all that kind of stuff, okay? Very important. This page, very important. Yeah, let's just go through an example here. Deciding if a coordinate point is on a line. Okay, so the question will say something like, decide if the point whatever is on the line, what y equals something. But in my example here, I have the coordinate points -2, 4, and it's on the line y equals 2x plus 10. Now, how are we going to do this? Fairly simple, okay? You're going to take the x value from the coordinate point and substitute it in the rule. So my x value is this -2 right here. So x equals -2. So I'm now going to just substitute it. Okay. Once you've done that step of substituting, you are now going to work out what the y value is. So let's just figure it out. So 2 times -2 is actually -4. And now I have -4 plus 10. Now, if you just work that out, you figure out that y equals to +6. Now, the final step is to compare the y values. So have a look at the coordinate point you were given. So the coordinate point we were given was -2 and 4. So we want y equals 4 after substituting x equals -2. Now, if you look on what we figured out in step 2, we quickly realized that we did not get y equals to +4. We in fact got y equals to 6. So now, just have a look. If it matches the point's y values, this point is on the line. If not, the point is not on the line. So that means because the y values are different, because since we want y equals to 4, but got y equals 6 after substituting, that means for point -2, 4 is not on the line, y equals 2x plus 10. And that's all you're going to do, okay? Because that's based on the question that we're given here, okay? Let's move on to the next topic. So there are many different types of lines that you need to know, okay? So these are just special lines on top of the regular graphing lines that you would typically see. The first one we're going to cover is a vertical line. So the vertical line is just a line that just vertical, that's it, okay? It just goes directly up That's all it is. Now, there's a general formula. This is the general formula we use, or general equation. Maybe equation will be better. And the general equation is x equals to b. Just note that this vertical line, some key features to it. It is parallel to the y-axis. It's just a number. So the letter B here is just a number. And the x-intercept is at b0. Okay. So this is the x-intercept right there. So whatever the value b is, that is going to be the x-intercept right there. Okay. Now the gradient for a vertical line is undefined. You must make sure you know that. Okay. Now, if I were to draw this graph myself, it'd be pretty straightforward. So let's just say they ask you to draw a line, and this is the equation that they give you. So you're first going to start out by drawing the x and the y axis. Okay. So just draw however big you want it. It doesn't really matter that much. So you're going to start off by labeling x and y axis. Okay. Next, you're going to scale. So remember, just use your ruler to sort of like, make an equal distance. So you see how like each marked out of place is around like equally the same and distance wise? You're going to do the same thing with all of them, okay? And you must cover the whole thing, okay? Now mine's not going to be perfect, but hopefully when you do yours, yours will be a lot more better than mine, okay? So I'm just roughly doing this right now. Now, you need to decide what your scaling is going to be, like how far apart you want to set each marking, okay? You can set it going a distance of 1. That doesn't bother me at all. So you can do that. You can set it as going up by 2. So let's just say it's 2, 4, 6, 8. That doesn't bother me at all. But you must make this decision, okay? I don't make that decision for you. You do that for yourself, okay? So just do that for now. I am just going to go by ones because I want to. And that's a choice that I've made. Now, something to show you all. So if you have a look at my x-axis here, my scaling across the x-axis is 1. Does that mean that my y-axis has to go up by 1 as well? Well, not really. You don't need to make it the same exact number across the x and the y-axis. I can make my x-axis go up by 1, and I can in fact make my y-axis go up by 2 instead. I can even make it go up by 3 if I really wanted to. But then again, that just depends on the context of the question. So because my context of the question is very simple, I am just going to go up by 1 instead. Okay? Just like that. Now, vertical line. Oh, that should be x equals. It should be x equals 2. What am I doing? I just got to change this. Can I type this out? Okay, delete. Arrow to the right. X. Uh, X, just like that. So x equals 2. So now that x equals 2 is done, and I know it's a vertical line, I'm just going to find where x equals 2 is on the x-axis. As you can see, I've just lined it up. And now I'm just going to draw a vertical line. Just like that. And I'm going to draw just like that. Now I'm going to write something else. You need to label the equation, the line, or label the line itself. And that means you write the equation. So what's the equation given to me? I have the equation x equals to 2. So I'm going to write that somewhere nearby this line, okay? So let's just do that real quick. X equals 2. And then finally, I'm going to label x and y intercepts if available. So what we mean by if available means if I can only draw one of the intercepts, I will just draw and label that one intercept. But if I can fit both, then I will write down both. Okay. Now with this type of line here, there's only the x-intercept. There's not really a y-intercept. So what you're going to do is mark right here where the line crosses the x-axis, aka the x-intercept, and you're just going to label that as in coordinate form. So 2, 0. And this is how you will score perfect marks in the graphing. Okay. So you're going to do that every single time. Next thing you're going to do is horizontal lines. So this is the general equation, general equation of a horizontal line. Y equals to C. So C is just a number, okay? That's all you need to know. And just remember the horizontal line is parallel to the x-axis. Now the y-intercept is located at 0C. Another thing important is the gradient equals to 0 whenever you're dealing with the horizontal line, okay? So make sure you remember all of this, okay? Let's do an example right now. I just need to change this real quick. So this needs to get changed. Uh, y equals to -3. So let's just draw this graph really quickly. So just do the same thing. Label x and y axis. Next thing, scaling. What was the other point? Label line. Right equation. And then label x and y intercepts if able. So let's just start scaling now. 1, 2, 3. Just like that, just like that, just like that, just like that. 4, 3, 2, 1. And we're going to do the same thing downwards. Hopefully yours is a lot more nicer than mine. I'm just eyeballing it right now. And like the more you do this, the more you start drawing graphs, the better your scaling will be without a ruler. So just because I've done this for such a long time, I'm quite comfortable with this, okay? All right, next thing, once we have scaled it, let's just draw a line. Y equals -3. So since C is -3, I just need to find where -3 is on the Y axis. We can see that it's right here. And then once you've lined up your ruler, you just draw a line across. Oh, no, that's not supposed to happen. Let's see if I could fix this. Hmm. Okay, that's a bit weird, but yeah. Okay, so, and that's my line right there. Now we're going to label the line. So write the equation, y equals to -3. And then next we're going to label the x and y intercepts if we're able to. Now I can see I have the y-intercept there. So I'm just going to label this 0, -3. And that's how you'll do it. The third thing we're going to do is lines that go through the origin. So Lines that go through the origin are just lines that go through the point 0, 0, and that's what it is. So this is the general equation right here. Now, with these kinds of lines here, the problem is the x and the y-intercept is at the same point, as you can see. X and y-intercept are the same point. Now, if you remember, based on what I've told you, you need two coordinate points to be able to draw a line, yeah? Now, this is not possible right now because I've only got one point available. So how you're going to find the second point is to substitute x equals 1. X equals 1 is the easiest value that you can substitute, okay? So substitute x equals to 1 into your equation. I'll just say into your rule. And that is how you're going to find the second point, okay? And I'll show you how to do that right now. So I have this example here, y equals 2x. So we know that the x-intercept and the y-intercept is at 0, 0. So now we're just going to substitute x equals to 1. So y equals to bracket 1 just like that. Now this just becomes 2 times 1, and 2 times 1 equals to 2. That means the coordinate point will be 1, 2. That's the second coordinate point right here. So this is the second coordinate point. Very, very important, okay? Yeah, let's just draw a line, okay? It's a bit weird, but we'll get around it. Mhm. So let's just label our x and y axis. Let's just scale it. Carry on 1, 2, 3. -1, -2, -3. -1, -2, -3. Then 1, 2, 3, 4. Okay. So now we know the first coordinate point is at the origin. So that's right here. So I've just circled it, the point 0, 0. And then we figured out the second coordinate point is at 1, 2. So we're just going to go along the x-axis, find 1, and then move upwards to find positive 2. It's right here. So now I have my 2 points right there. Next thing I'm going to do is, once I've marked those 2 points, just grab your ruler and draw a line through them, okay? So pretty simple, just like that. Now hopefully yours is a lot nicer than mine. Oh, mine is definitely terrible, so I'm just going to fix that up. Just going to change the angle of my ruler. Oh, something's wrong. Maybe if I set it up like that, that will change it. There we go. Just like this. Now I'm going to label the line y equals 2x. And then you typically label both the x and the y intercepts. Now, fortunately, the x and the y intercepts are the same coordinate point. So you just put an arrow there and just say, okay, that's 0, 0, and you're done. Just like that. Okay. And this is how you get perfect marks. Continuing on, so let's start talking about gradients, okay? So with gradients, there's a four different types of gradients. Make sure you know the difference, okay? I've sort of covered it before. I've covered two of them already, but we'll just cover all four, okay? So the first one is the positive gradient. This means that the value m is a positive number, okay? So the value m is a positive number. Now, if you look from left to right on the x-axis, the y values are increasing every time. So if you draw a line like this, as you can see, every time you move along the x-axis towards the right, you can see my y values are increasing every single time. So this is an example of a positive gradient graph. Negative gradient, so this means the value m is a negative number. Now, when you look from left to right on the x-axis, the y values are decreasing every time. Okay, so just like that. This is draw a rough sketch. And as you can see here, this is my line. Looking at it from left to right, you can see that my line is actually going down, like the y value wise. It's decreasing every single time I move to the right. Okay, so that's how you can tell. Now, zero gradient, we sort of touched on that before. We went through an example of a zero gradient line, and this is in fact the horizontal line right here. So the gradient is actually zero. So whenever your gradient is zero, you always end up with a horizontal line. Okay, that's just the fact. Okay, if you want me to show you proof, I can show you that right now. Now, if you remember correctly, the general equation of a line is this. Okay, general equation. Now, if I were to substitute m equals 0, I end up with y equals to 0x plus c. Now, if you remember correctly, this just means 0 times x. And you actually end up with 0 plus c, because anything multiplied by 0 is just 0. And 0 plus c equals to c. So that's why this equation here, y equals c, is what we use to represent the equation of a horizontal line, and the gradient is 0. Okay? Now, undefined gradient. So you can't measure what m is. Okay? Since we can't measure it, we just say it's undefined. Now, this is only for vertical lines, and just remember, this is the general equation. Now, if you want me to show you proof, I can do so. So if you remember from gradients, actually, I'll show it to you the next slide, and I'll prove it to you then once we cover the next slide, okay? So, so what is the gradient? This is the formula that you use. M equals rise over run, okay? Vertical change, rise, horizontal run, okay? Very important. Just like that. Now, if you look at my diagram on the right here, it looks like a right angle triangle, but what we're doing is pretty special with it, okay? So the slanted line going up, that is my actual line right there. And to determine how steep this line actually is, we use the run and the rise to sort of figure that out exactly, okay? So that's what we're going to do. Now, if we refer back to this undefined gradient, just remember this line, this vertical line is just like that. Now, if the whole concept is to try and make a triangle out of this, you can't really make a triangle out of this line. You can't make a triangle. It's literally impossible. Yeah. So you can't make a triangle. So you can't determine what run is. Because remember, from our line, we have rise, we have run, and this is our line right here. Now, looking at this graph here, you can determine rise, okay? You can determine the rise because the rise is a vertical change, and we can see from a vertical line, there's so much vertical change, but you can't determine the run because there's no horizontal change, okay? And since we don't know what it is, we just call it undefined, okay? So just remember that. Now, let's just do an example. Calculate the gradient given the graph. So they've given you two coordinate points. So as we can see, we're given the coordinate points 3, 6 and 1, 2. What I'm going to do is I'm going to make a triangle. Let me just increase the thickness of this. So we're just going to make a triangle. And then you're just going to ask yourself, what is the rise? What is the run? So remember, rise is the vertical change. So look at the values on the y coordinates. Like on the coordinate points, look at the y values there. So I have 6 and I have 2. What's the change there? So if you just do rise, it's just 6 minus 2, which equals to 4. That means my rise is 4. Now, if I were to determine my run, look at my x values now. So what's 3 minus 1? 3 minus 1 is actually just 2. So now I know that my rise is 4 and my run is 2. So if we substitute those values in exactly where how they are, so rise being 4, run being 2, we have 4 over 2. Now you can pretty much simplify 4 over 2 to be positive 2. That means m equals to 2, just like that. For part B, I'll just sort of write out the equation first, and then we'll figure out what rise and run are. Okay? All right, so let's have a look here. So I'm going to make my triangle just like that. Now let's have a look. Let's look at the rise. So my rise is, let's look at the y values, 3 and 0. I'm assuming that's a 0 right there. So my rise is going to be 3 minus 0, which is 3. Now let's have a look at my x values here. Run like this. So I'm just going to go from, let's see here, 4 to 7. So 7 minus 4, which equals to 3 as well. Okay? So that's cool and all. But the next important thing is you need to look at the graph. Okay? What type of gradient is it? So just judging by the slope of it, we can see that as x moves from left to right, we can see our y values are actually going downwards. So this is in fact a negative gradient. So what you're going to do is you're just going to slap a negative sign in the middle somewhere. Doesn't matter where you put it. And then just write down the value of rise and run. So my rise is 3, my run is also 3. And then you just figure out, okay, what's 3 divided by 3? That's negative 1. That means m equals to negative 1. Just like that, okay? And these are just some further examples to highlight what we're doing. So let's just go through it really quickly. I'm just going to pick out 2 coordinate points. So I always typically use the x-axis and the y-axis, but if that's too small for you, just pick another point. Just like that. So I have the coordinate points here 2, 6, and I also have the coordinate point here negative 1, 0. Okay? And now you just determine what the rise and run is. So as I can see here that my rise is 4. My run is going to be negative 1. So it starts from negative 1, goes all the way to positive 2, 1, 2, 3. So it's 3. And because my graph is a gradient, is a positive gradient, I can just write confidently m equals rise over run, 6 over 3, which equals to 2. Now, let's have a look here. Going to use these values here. So so I'm just going to write the coordinate points here, 0, 3, and 2, 0. And the rise is going to be 3. The run is 2. So m equals to rise over run. And then just have a look, okay, when my x values are moving across from left to right, my y values are decreasing. So I know it's going to be a negative gradient. And since we know what rise and run now, we can just substitute the values in. So that means m equals to negative 3 over 2, just like that. Now you just have a look at this graph here. You can't really make a triangle, and you know it's a horizontal line. So you just say m equals to 0. And then finally, for this one, this is a vertical line. So it is a vertical line. That means m equals undefined. It's- Okay. Now, finding the gradient using two coordinate points. So this is when no graph is given. Okay. So they might give it to you. They actually might just give you the coordinate points straight up, and it's your job to sort of figure it out. Now, what you're going to do is label the coordinate points as the following: x1, y1, and x2, y2. Okay. All this means is the first coordinate point, and then you got the second coordinate, and then you just substitute. So you're going to substitute respectively the values. Okay. So let's just go through an example right now. So I'm going to label as x1, y1. Okay. I'll just label this as x1, x1, x2, and then y1, y2, just like that. Okay. Just like that. So that means m equals to y2 minus y1 over x2 minus x1, just like this. And now we're just going to substitute it. Y2 is the number 6 minus y1, which is the number 4, over x2 being 5 minus x1, which is 3. Now you just simplify the numerators and the denominators. 6 minus 4 is 2, 5 minus 3 is 2, and 2 over 2 is just 1. That means m equals to 1. Now you're just going to do the same thing with the next example here. I'll just start out by writing my formula, and then I'll just fill this out. There we go, just like that. And let's just substitute it in. Negative 3 minus 6 over 1 minus negative 3, just like that. Now you got to be careful, okay, because when these happens, you have to combine the signs, just like that. So it now becomes negative 9 over 1 plus 3, which equals to negative 9 over 4. That means m equals to negative 9 over 4, just like that, okay? Now I'll stop the video here and then I'll just make the second half of the videos, okay? So this is technically part 1 so far. You must make sure you understand part 1 before you move on to part 2, okay? So yeah, just take your time with it.